Have you ever noticed how a cold drink glass gets foggy on a warm day, or seen clouds forming in the sky? These common phenomena are actually visible clues about a fascinating process happening all around us. They show us what occurs when the air around us becomes completely full of moisture. When air reaches water vapor saturation, it means the air can no longer hold all the water vapor it contains as an invisible gas. At this critical point, any additional water vapor introduced, or any cooling of the air, will cause the excess water to change its state. This primarily leads to condensation, where the gaseous water vapor transforms into tiny liquid water droplets or even ice crystals, depending on the temperature. The fundamental reason this happens lies in the molecular behavior of water and air. Air is a mixture of various gases, and water vapor exists as individual water molecules interspersed among these gas molecules. The amount of water vapor that air can hold is directly dependent on its temperature. Warmer air has more energy, allowing water molecules to move faster and stay in a gaseous state. Conversely, colder air has less energy, causing water molecules to slow down and bond together, changing from a gas to a liquid or solid. When the air is saturated, the rate at which water molecules evaporate equals the rate at which they condense, establishing a dynamic equilibrium. You can observe this principle directly by cooling a surface. For instance, when warm, humid air comes into contact with a cooler object, like the outside of a cold beverage can or a car windshield on a cool morning, the air immediately adjacent to that surface cools down. If this cooling brings the air temperature down to its dew point, which is the temperature at which saturation occurs, then condensation will begin. This results in the formation of visible liquid water droplets on the surface, commonly known as dew or condensation. This concept is crucial to understanding Earth's climate and weather patterns. The specific humidity, which is the ratio of water vapor mass to total moist air mass, increases as air temperature rises. However, it is the relative humidity, expressed as a percentage, that tells us how close the air is to saturation at its current temperature. When relative humidity reaches 100%, the air is saturated, and water can no longer remain solely in its vapor phase. This saturation point drives cloud formation, precipitation, and even the feeling of mugginess on a hot day. The phase change releases latent heat, which is an important energy source in atmospheric processes. Ultimately, recognizing when air reaches water vapor saturation provides a clear understanding of why we experience fog, clouds, and precipitation. It highlights the invisible but powerful interplay between temperature, moisture, and the dynamic processes that shape our daily weather. This fundamental principle of thermodynamics explains how water cycles through our atmosphere, from an unseen gas to the visible water we depend upon.
If you love learning about water, like, subscribe, and keep exploring with us.